The universe may be infinite, but so is our curiosity, it seems. Today we'll be looking at three aspects of space adventure: the building of space stations, the first manned flight to Mars, and Star Wars, Earth's first orbiting defense system. When men of the past gazed at the sky, they saw about the same thing we do now, but they didn't know much about the universe. The Greeks were the first to suggest that our planet was not flat, but round, like a ball. They thought circular shapes were perfect, the bases of the universe. They believed the Earth was a fixed sphere, the center of everything, surrounded by a series of concentric spheres. All the planets were positioned in one of those spheres, and all the stars in the farthest sphere. They also thought the spheres were made of crystal, and that the movement of the stars produced what their scholars termed the music of the sphere. Very poetic. It's called the Ptolemaic system, after its inventor, Ptolemy. We've soared through space at the speed of light, encountered strange aliens who sought our doom, conquered planet after planet. Science fiction has taken us much further than our scientists have. But truth is rapidly gaining on fiction. Take the space station. It's now a reality. Thanks to space stations, man can now dream of extending the boundaries of his natural habitat. By transforming space into an off-planet suburb of the Earth, he could further its exploitation and perhaps even its colonization. The Soviets have been using space stations for 15 years. They are habitable structures, placed in orbit a few hundred kilometers above the Earth. The Soviets have already built 7 in the Salyut series. The first 5 consisted of a single main module of about 20 tons, capable of accommodating 2 cosmonauts. But these early stations couldn't be refueled. This problem was overcome with the construction of Salyut Stations 6 and 7, which were equipped with 2 cargo collars. This allowed unmanned Progress vessels to couple with the stations to provide fuel, supplies, and equipment, and manned Soyuz capsules to replace crew members. Capitalizing on the experience they acquired with the Salyut stations, the Soviets are now aiming to complete their new Mir space station by 1992. It will weigh more than 150 tons and accommodate 6 cosmonauts. The Americans, in collaboration with Japan, Canada, and 9 European countries, are presently constructing the space station Freedom. It will not be ready to house its first astronaut until 1995. Freedom will consist of a dorsal spine 100 meters long, connected to 4 pressurized modules. There will be 1 residence module with living quarters for 8 and 3 laboratory modules. Since 1985, American astronauts have been testing an assembly technique which will allow them to construct their orbiting station in space. The testing is being carried out on Earth in enormous water tanks. Here, the future builders become familiar with building techniques and the conditions they will encounter in space. Their task consists of assembling 5-meter cubic modules. A few years from now, modules like this will be the basic building block of the Freedom Space Station. Once assembled by the astronauts, these cubes can be moved into place with the help of the Canadarm, or remote manipulator system.
Whether American or Soviet, the space stations will use the same energy source. Huge solar panels will harness the energy of the sun and transform it into electricity. Also being considered are large concave mirrors. Like a magnifying glass, the mirrors would focus the sun's rays on a fluid. Once heated, the fluid would drive electric turbines. Freedom's modules will provide living quarters, laboratories, and a hangar where satellites could be repaired. Designers have even designed a vehicle for towing disabled satellites to the hangar for servicing. Freedom's astronauts will breathe air regenerated by chemical filters, and some of their drinking water will be obtained by passing the ambient air over chilled plates to condense its humidity. However, the men and women who inhabit these stations will fall heir to the drawbacks of life in space. For instance, in a weightless environment, blood no longer descends naturally into the legs, but concentrates in the head. But weightlessness also offers some exciting benefits, such as the creation of solid and rigid forms of steel that can float. In the absence of gravity, gas bubbles incorporated into a molten metal are distributed uniformly. On Earth, these bubbles, being lighter than metal, rise to the surface and escape from the mixture. The principal advantage of space stations is that they will allow man to mount and supply prolonged missions into deeper space. Their existence is as essential to the eventual establishment of a permanent lunar base as it is to the undertaking of a flight to Mars.
Have you ever watched a point of light blazing through the sky and wondered if it was a flying saucer filled with Martians coming to invade the Earth? We've been fascinated for years by the red planet and its little green men. Even though Mars is 56 million kilometers away when its orbit reaches the closest to the Earth's, it still qualifies as our closest neighbor. We've always thought that if there was life other than here on Earth, it would likely be on Mars. Already, space agencies have initial plans on the drawing board for a manned mission to Mars. But even optimists predict that it won't happen until sometime in the next century. In time, we could settle on it. Someday, out on Mars, Earth's future generations may have the chance to live mankind's greatest adventure.
We will likely land on Mars sometime in the 21st century. When we do, we will be opening up a brand new frontier in space exploration. This historic event will mark man's first journey beyond his planet of origin. But our interest in Mars isn't confined to its exploration. Perhaps above all, man is attracted to Mars by its potential for colonization. Scientists believe they could grow plant forms on the surface of Mars, such as algae and lichen. Gradually, through photosynthesis, these plants would transform the carbon dioxide, which makes up 95% of the Martian atmosphere, into oxygen. The water the plants would need to survive would be drawn from the red planet's immense reserves, frozen into the ground or deposited in its polar ice caps. In a few thousand years, the atmosphere and climate of Mars could be modified completely. The dream of modifying the Martian atmosphere may or may not come true, but already the Russians and the Americans are working on plans for its conquest. In any case, the interplanetary spacecraft needed for such a mission will be so huge it will have to be assembled in space from modules prefabricated on Earth. Once loaded, the vessel could weigh as much as 2,000 tons. The air, water, food, and supplies needed to ensure the survival of an 8-member crew could alone weigh 40 tons. To minimize risk, the Americans have developed a scenario whereby the trip to Mars will be undertaken by 3 vessels launched from Earth orbit. These manned ships would be followed by an independent cargo vessel. On the way to Mars, they will all link together. Then the resultant craft will use a rotating motion to produce the artificial gravity needed to prevent the astronauts' bones and muscles from deteriorating over the course of the long space flight. To reach Mars, the spacecraft will follow Holman's trajectory. This trajectory establishes the minimum output of energy needed to travel between 2 planets in our solar system. On its journey to the red planet, the spacecraft will follow a route taking it ever closer to Mars's orbit around the Sun. As it is influenced more and more by Mars's gravitational pull, the craft will benefit from a significant acceleration. Its trajectory will allow it to complete the voyage to Mars in 280 days, but the trip could be shorter if the craft has enough fuel on board to increase its acceleration on approach. The spacecraft's interior will be designed to allow its crew to live and work during the long months of the voyage. Before entering Mars's orbit, small shuttles will be launched from the main vessel to carry crew and cargo to the planet's surface. The shuttles will use the resistance of the Martian atmosphere to slow their descent. This landing technique will conserve fuel, so the fuel can be chiefly used for takeoff and altering course. The astronauts' first job will be to establish a permanent base. They will use some of their shuttles for the job after they've been unloaded. To shield the base from the intense solar radiation and cosmic rays, they will cover it with a thick layer of soil. On landing, the astronauts will use a small nuclear reactor and various other devices to provide the elements they'll need to survive. Water will be produced by compressing and cooling the Martian air. A gas extractor will produce the oxygen needed to breathe. Even rocket fuel could be manufactured from gases in the Martian atmosphere. Greenhouses built of light plastic and metals will allow the cultivation of food. Using the permanent base as their headquarters, the crew will undertake exploratory scientific missions. They will look for fossils, which would be evidence of previous life forms, and search for clues to the red planet's geological development. Only at the end of a full year, when the Earth's gravitational pull is available for the journey home, will Earth's first interplanetary explorers complete their mission. The technology needed for the first flights to Mars continues to be developed. The Russians and the Americans have robot exploratory missions both underway, and in the planning stages they will gather the data and provide the technical and operational background required to mount the first manned interplanetary mission.
I bet you'd love to have a chance to go off into space for, 2 or 3 days. But would you agree to go for 2 or 3 years? We have no way of knowing if human beings can survive such a long mission. We know very little about the effects of cosmic rays, for example. Would it be better if we sent robots on our space missions and made sure the risk to human life was kept as low as possible? The authorities are wondering. This doesn't stop new space programs from being announced almost daily. Rockets, satellites, shuttles, probes. Why do we invest so much in the conquest of space? For the honor it brings the nation? In the hope of future profit? For defense purposes? The Americans have their Star Wars project, but it's designed to protect American territory here on Earth.
To safeguard their nation from full-scale nuclear attack, American military strategists have devised a colossal project. It requires the deployment of a vast network of satellites between now and the year 2000. Their job will be to detect and destroy any enemy missile before it reaches American soil. Its official name is the Strategic Defense Initiative, but the Space Shield is better known by its nickname, Star Wars. Star Wars is being designed to neutralize one major threat, the 1,500 intercontinental ballistic missiles based in the Soviet Union. Less than 5 minutes after being launched, these missiles can deliver 10,000 nuclear warheads into space, all targeted for the United States. Star Wars Watchdog system consists of surveillance satellites placed in geostationary orbit over Soviet territory. This detection and communications network dictates the Space Shield's defense strategy. Star Wars itself consists of 4 lines of defense, which correspond to a missile's 4 phases of flight. Each phase represents a possibility for interception. A missile's first flight phase extends from ignition to when it leaves the Earth's atmosphere. This is the optimum time to destroy the missile. The heat released by its rockets is easy to detect and track. Plus, if the missile is carrying multiple nuclear warheads, as is often the case, all the warheads will be destroyed by shooting down the single missile. During the second flight phase, the post-combustion phase, the missile's nose cone separates from the rocket booster. Laser beams are used to destroy the missile during these first 2 flight phases. Some laser beams fired from bases on Earth will be reflected toward their target missile by mobile mirrors orbiting in space. Others, fired from satellites, will be aimed directly at their targets. To produce a laser beam, light or electrical energy is applied to a solid or a gas in a tube. This tube is closed at both ends by mirrors. Once excited, the atoms of the gas or solid emit tiny particles of light energy called photons. The photons are emitted in all directions, but some travel parallel to the tube. These photons bounce back and forth between the 2 mirrors, striking other atoms in their path as they go. This creates other photons of the same wavelength, which follow the same path. The chain reaction is allowed to continue until the concentration of photons traveling in the same direction is great enough to fire a laser beam through the semi-transparent mirror at one end of the tube. Like light, the beam travels at 300,000 kilometers per second. The intensity of a laser beam depends on the amount of energy used to excite the atoms and the type of gas or solid in the tube. Some lasers are harmless, others highly destructive. Other weapons will also be used, such as kinetic interceptors, which fire solid objects over great distances to destroy their targets. In the third flight phase, the missile's nose cone fires its lethal cargo. Now the Space Shield must destroy dozens of targets. Some are in fact nuclear warheads, but others are merely decoys. Star Wars' greatest challenge is to distinguish between the decoys and the warheads. If the selection system now under study is adopted, Star Wars could destroy the true warheads with laser beams, neutral particle beams, or kinetic interceptors. A missile which penetrates Star Wars' first 3 lines of defense enters its final flight phase. The decoys burn up on entering Earth's atmosphere, but the warheads continue on course. They are now only 2 minutes from impact. At this stage, the best defense would be computer-guided anti-missiles. Laser beams fired from bases on Earth would also assist. However, many scientists doubt that such a complex system can be truly effective, or more importantly, maintain peace.
The telescope on Mount Palomar in California enables us to see the clouds of Magellan, 2 galaxies, 160,000 light years from Earth. No one's established any limit to the universe. It's too vast. But just look at it this way. When you go out to wish upon a star some night, you've got billions and billions to choose from.